In this video, we're going to continue the method of u substitution and apply it to now a definite integral. Before we do that, I want to remind you that it's really important that our notation is correct. So if you have x is here, this needs to be dx. If these are u's, this needs to be du. And we can't just change it. We have to be very strategic on the substitutions to make sure it's equivalent. So before we go through a definite integral, we're going to go through one more indefinite integral. So just remember, we want to choose u to be some inside function, or perhaps maybe a denominator, but we only want to choose the inside. We usually don't want to start with a whole thing. So let's just start with this guy right here. So 4x squared plus 3, and then its derivative is 8x. And then don't forget we have dx there, because remember this is the derivative of u with respect to x, and we're multiplying it over here so that it becomes a differential. Now we're going to make our substitution. So our substitution here, first we plug in u, so that goes away, and we then have a u to the 6th power in the denominator. We still have an x and a dx that need replacing, and we have part of it here. We need to get rid of the 8, and remember, since this is an equation, I can use inverse operations to isolate that x dx. So x dx equals 1/8 du, and that means I can swap out x dx and plug in 1/8 du. Since this is a coefficient, when I plug it in, I'm actually going to plug it in outside, and then my du could go here, or I'm going to put it right here, since that's how we usually see these written. So now, when I want to clean this up just a bit, there's nothing on the top, which means there's a 1. And then remember, in order to integrate, I need this guy to be up in the numerator. So I'm really integrating 1/8 times the integral of u to the negative 6 du. And when I integrate, again, I'm going to add 1 to that exponent. And then I'm going to divide. So when I divide here by -5, I get -1 over 40. And then you have plus c. Just don't forget, I don't want to see a u in my answer. Since there's nothing left to do, this u is still there. So I must replace it with what I chose u to equal. So it's -1 over 40 times 4x squared plus 3 to the -5 plus c. Now we're going to look at something that is a definite integral. So remember that when this is dx, it tells me that x is the only variable allowed in the problem. It also tells me that these are values of x. If I change this to u, then I need to make sure u's are in the value of the problem, and these are going to have to turn into values of u. So let's begin by doing the same process that we did before. So we're going to choose u to be an inner function. So in this case, I'm going to make this choice first. So I'll have x squared plus 1. And then remember, I'm going to always have to replace dx. So I always must find du. And du is going to be just the differential of u. So it's going to be 2x dx. Now I would go ahead and start replacing things and see if there's more work you need to do. And a lot of times there will be, but sometimes there won't. So I'm going to replace this with u first. So I get u to the power of 3. And I need to still replace an x and a dx. I have that here. So I'm going to divide both sides by 2 to see that 1/2 du equals x dx. And now my x dx can go out, and I can substitute 1/2 du. Now, we're almost done replacing, other than the fact that if this is a u, my upper and lower limits must be u values. And right now these are x values. So if x equals 0, I need to figure out a way to turn that into a value of u. And it just so happens we have an equation here for u that uses values of x. So I'm going to plug in my bounds to get new bounds. So here I'm going to have u of 0. I'm just plugging 0 into this function equals 0 plus 1 or 1. So instead of using 0 as my lower limit, I'm going to use 1. Now I'm going to plug in 1 since that was my upper limit, and I'm trying to replace it, so I get 1 squared plus 1, which is 2. So my new upper limit is 2. And now I'm actually done with all of this. Now I have a nice, pretty equation. Remember, this is asking for area under a curve. Because we have bounds, this is asking for a numerical answer. So there's not going to be any u's. I have no reason to ever use u again. So when I integrate, I'm going to add 1 to the exponent, and I'm going to divide by that new exponent. So my new coefficient is 1 over 8. And remember here, there is no plus c, but I'm going to evaluate from 1 to 2. Now remember, these are values of u, so I can only plug them into u, which is what I have here, so that's a good thing. So I'm going to pull down my coefficients, and this is all I'm going to evaluate from 1 to 2. So I'm going to plug in 2, I'm going to plug in 1, and subtract. So here, 2 to the 4th is 16, and I'll get 15 over 8. Okay? Our very last example, again, we're going to follow the same idea. So we're going to make a choice for u to be the inner function. So I have 1 plus x to the 3rd. du is going to have to be found, and it's 3x squared dx. And sometimes we have more work to do. In this case, when I plug in u for that, I'm going to have radical u. I still need to replace 3x squared dx, which I have perfectly here. So I'm just going to swap in du when I swap those out. I still have to substitute these guys and turn them into values of u. So I'm going to, since these are values of x, I'm going to plug them into this equation here. So u of 0 is 1 plus 0. So my lower bound is 1. My new upper bound, I'm going to take my old upper bound, plug it in. I'll get 1 plus 2 cubed, which is 9. And now I have a nice integral. The only other thing I need to do is make sure that I write this as a power. So I'm really integrating from 1 to 9, u to the 1/2 du. So I'm going to add 1 to my exponent, and I'm going to divide here. So I'm left with 2/3, and I'm evaluating that from 1 to 9. Remember, if you have a coefficient, it can just drop down, and we really only need to plug our values in to the u. And remember, we're plugging this directly in for u because this is a u value. It's not an x value, it's a u value. So remember, this is equivalent to the square root of 9 to the 3rd power minus the square root of 1 to the 3rd power. And if I take 3 to the 3rd, I get 27. And if I simplify, I'll have 26 times 2, which is 52, all over 3. And notice, there's no u in here, so there's no reason to ever go back and use this ever again.